Dear Tim and Moby, how does natural selection work? From Fred D. Many species have come and gone during Earth's history. For instance, there are no more dinosaurs. By the same token, when dinosaurs walked the Earth, there were no people yet. Well, that's natural selection at work. Sure, but first, I gotta tell you a story. Back in the 1800s, a scientist named Charles Darwin went on an historic expedition to the Galapagos Islands and noticed something strange about the birds there. Each of the islands had its own unique species of finch. They were all very similar to one another, but their beaks were radically different sizes and shapes. On islands with lots of fruit trees, the finches had beaks that were useful for eating fruit. On islands with a lot of insects, the finches had thin beaks that could pick up a single bug. And so on. This got Darwin thinking. Eventually, he decided that all of the finches could have easily come from a common ancestor and become more specialized to suit their environments. The end. I'll explain. You just have to understand some stuff first. Life isn't always easy. Living things always have to compete for resources. Even in the nicest environment, there may be a shortage of food, or water, or even space. And a lot of plants and animals have to worry about being eaten. All these things are called environmental pressures. Got that? Now, in any given population of plants or animals, there are always variations. Look at a family of brothers and sisters. You'll see what I mean. Nobody's exactly the same. Right, except for maybe twins. Some variations, called mutations, can be passed on to your kids. These mutations can be caused by mistakes that happen when your DNA copies itself, or by outside influences like radiation or chemicals. So what do mutations have to do with environmental pressures? Well, imagine a coral reef with some little green fish living near it. There's a big fish that lives there too, and he likes to eat the little fish. As with any population of animals, the green fish have their share of mutations. Some mutations aren't so good. Other mutations, however, can be seen as favorable. A fish the same color as the reef is harder to spot, so it's less likely to get eaten. It has a better chance of living long enough to reproduce. And if it passes on its colors to its offspring, then over time the entire population may be the same color as the reef, as the brighter fish succumb to the environmental pressure of being eaten. This system of natural selection is sometimes called survival of the fittest, and it's the driving force behind the theory of evolution. These changes can take various amounts of time. Some are quick, and some take millions of years. Still, natural selection is pretty hard to miss. Just look at the variety of life on Earth caused by the different environmental pressures. One neat consequence of the theory of evolution is that all life on Earth is connected. Some scientists would even say that if you pick any two living things and go back far enough in time, you'll find that they have a common ancestor, just like Darwin's finches. In his book, The Origin of Species, Charles Darwin compares the almost endless complexity of life to a massive tree. Some branches don't work out, and they drop off, becoming extinct. Other branches thrive and become trees in their own right and contribute to the amazing diversity of life. I can totally see you. Yes, I can.